I'm Laura, and I'm an iOS engineer at Meetup. Today, I'm excited to talk to you about architecting a robust color system in your apps. Over the last 2 years, my colleagues and I have had the opportunity to enact a radical change to the Meetup iOS codebase. This wasn't just a shift from Objective-C to Swift. Instead, we threw away the existing repository, created a new Xcode project, and began anew from line 1. This was an incredible chance to rethink the Meetup's app infrastructure. Knowing that significant design iterations lay ahead, I undertook the task of constructing our color system. I sought to develop a scalable system amenable to change. Today, I'm going to share some concepts that I keep in mind when I'm configuring an app's appearance. First, I'll describe how to architect a basic color system that readily adapts to design iterations. Then, I'll explain how to leverage Swift's protocols and protocol extensions to update an app's color palette at runtime. Afterwards, I'll discuss legibility considerations when making design choices with color. I'll go over some tools users with limited color vision may use when experiencing any iOS app. I'll conclude with a thought about applying this color system for testing your app with sightedness concerns in mind. Now you may be wondering what would make building a color system useful. For starters, accessing colors from a centralized location is convenient. It eliminates the hassle of hunting for specific RGB values each time they're needed to configure a UI element. Defining colors in this manner also enforces a consistent color palette throughout your platform. This helps create a uniform visual experience for your users. Most importantly, adhering to these patterns will simplify iterating on your app's appearance. This adaptability is sure to make both your designers and developers happy. Let's be clear. App redesigns are not exclusively linked to a major company rebranding. Apple's human interface guidelines change periodically. The end of the realism associated with skeuomorphism, ushered in with iOS 7's flat design, may be the most memorable, but iOS 10 also brought about significant visual change. Apple Music's big, bold headers and sleek, solid backgrounds provide an excellent example of the new styling. In 2016, Apple made major strides by including support for dark themes in several of its products. The introduction of a dark mode for Yosemite's toolbar was novel, but since then, tvOS 10's UI trait collection properties and interface builder support provided developers a serious incentive to configure dark mode in Apple TV apps. With rumors of OLED iPhones on the horizon, the time is right to consider what a dark theme might look like in your iOS app too. As this reviewer has aptly observed, your color choices have significant impact upon your users' experiences. With the value of creating a color system in mind, we may now discuss options for our architecture. We have two choices to consider. Do we define our colors within Interface Builder or programmatically? The question of customizing our view's appearance using either approach can be polarizing. Now, Interface Builder has become extremely powerful over the years. It's likely that you're already creating your views in storyboards and nibs. With access to a color picker from the utility panel, configuring UI elements in Interface Builder is easy. Did you know that iOS developers and designers can share color palettes using CLR files? These files work both in Sketch and in Xcode. The prospect of setting colors from Interface Builder by using this shared file is compelling. Natasha the robot has written an excellent blog post detailing this process. I encourage you all to check it out. Unfortunately, colors set on UI elements in Interface Builder lack a common reference. Although your brand color might never change, other colors are likely to update. Even when using a shared CLR file, changing these colors using Interface Builder involves going through each nib to set new colors on affected elements. It's such a hassle. Interface Builder for iOS currently supports setting only a single color on each UI element attribute. This limitation, though perfectly reasonable, prevents us from customizing a view for multiple themes without programmatic assistance. Luckily, defining UI color objects programmatically resolves our common reference issue. Modifying all occurrences of a particular color involves updating code in a single location. This offers several benefits. We can be certain that all UI elements referencing a color update as intended. As an added bonus, the diff created by this change touches only one file, a benefit I'm sure your teammates will appreciate when reviewing your pull request. And unlike the Interface Builder approach, programmatically referencing colors helps allow you to create custom themes. We'll begin by creating a UI color extension to store our colors. This will allow us to access our custom colors in much the same way you would access other colors defined by UIKit. Within this extension, we should include a nested struct to define our palette. Ideally, palette colors should include names indicative of the color's hue. This will help us distinguish between colors in our palette at a glance. If you share your designs between developers and designers using a utility like Zeppelin, Zeppelin's existing color export tools may simplify this process. As you can see from this code sample, the colors defined within our palette struct are immediately identifiable. Even without looking at the color corresponding to its RGBA value, we can envision the color represented by cerulean blue. Because colors defined in this palette will remain constant, each color may be declared both static and immutable. I've found that, unless transparency is explicitly desired, it's preferable to specify colors using an alpha value of 1. This prevents unintended blending from occurring between foreground and background UI elements. Although you may not experience visual consequences on white backgrounds, the ramifications of using views with transparency may be glaring in conjunction with some custom themes. I'd recommend calling the withAlpha component function as needed for the specific instance requiring a low alpha value when defining a translucent color in your palette, rather than defining a translucent color. We can now define colors within our UI color extension referring to those colors in our palette. Now, Swift 3 introduced the ability to define class computed properties from within extensions. Since defining a color does not typically involve arguments to dictate the color's appearance, class computed properties are a natural choice. This is the approach recommended by the UI Color API reference when creating color objects with a predefined hue. Before Swift 3, class functions served this purpose. should your colors rely on an argument to display appropriately, class functions continue to be a valuable option. We'll revisit this approach when integrating custom themes. We should access these class colors, not palette colors, when establishing the appearance of UI elements. Unlike our palette colors, which are identified by hue, these colors should be identified by responsibility. Consider this example from the UI Color API reference. We have two varieties of text color specified. Dark, for displaying text on light backgrounds, and light, for displaying text on dark backgrounds. The responsibility each color has is clear. We want to expand upon this precedent for all roles colors play in our app. Common color responsibilities include text styles, feedback indicators, background styles, and button states. Of course, there's no need to provide a one-to-one mapping between colors in your color palette and colors returned in your color roles. In this example, both button-based and text-based roles make use of the same desaturated palette hues. It's possible that you may, in the future, wish to change the button colors to something more vibrant. In that case, it's easier to change the hue used by the button's color role than it would be to search for and modify only some occurrences of that common palette color. When defining colors, please also consider the contrast between foreground and background elements. Colors appearing well on light backgrounds might not pop on darker backgrounds. Depending on your app's design, it may be beneficial to include an inverted variant for each role. These colors don't need to be a true inversion of the color's RGB values. Instead, these colors should provide sufficient contrast between foreground and background colors. A contrast ratio calculator tool may be useful when designing a color palette for display on both light and dark backgrounds. I've included a link to such a utility at the end of this presentation. With the colors in our color system finally in place, we can now begin the task of integrating themes. If you've previously added support for dynamic type updates in your app, this approach may feel familiar. When the user performs an action, initiating a change in the app's appearance, this information must be communicated to all views requiring an update. As this information is of interest to an unclear number of recipients, we should emit this message using Notification Center. Interested parties should then respond to this information at the controller level. We'll begin by introducing a new protocol, ColorUpdatable. This protocol will allow all color updating types to share a common interface. Changes made using this interface reflect upon ColorUpdatable conforming objects accordingly. The protocol itself is straightforward. The theme property stores which state the conforming object should display. We need this property to configure the views appropriately during its initial setup. Next, the update colors for theme function is responsible for updating the colors of all UI elements contained in the conforming object. Label text colors, view background colors, and tint colors should all be specified here. If your view contains children also conforming to ColorUpdatable, this function should call through to their update colors for theme functions as well. With our common ColorUpdatable interface established, we can now address the task of observing color update messages. To that end, we must create yet another protocol. We'll call it ColorChangeObserving. For convenience, the ColorChangeObserving protocol will contain functions to both add and remove observance of notifications indicating that the color theme has changed. In order to properly respond to these notifications, the protocol should declare a function to call whenever the notification center message is observed. There's not much to it. Both adding and removing the theme change observers will call through to Notification Center's add and remove observer methods, pre-configured with the name of the color theme change notification. Because we need to post a custom notification indicating that the color theme has changed, it would be beneficial to limit the number of clients privy to that implementation detail. We'll be able to add an extension on ColorChangeObserving to isolate this information. The selector of the observer will be the didChangeColor theme notification function included in this protocol. In practice, you should call the function to add the color theme change observer early in your controller's lifecycle. This should ensure that posted theme change messages are received. Upon receiving the message, the didChangeColor theme notification function will be called. We can continue to extend our ColorChangeObserving protocol to provide it with some default behavior. First, we have a few helper functions to create. As I mentioned before, we need to post a custom notification indicating that the color theme has changed. The new theme we're reconfiguring our views to display should be included in this notification's user info dictionary. The theme from notification function simply handles the implementation details of extracting the theme from the notification's user info, returning nil if the theme is not found. Now, the real magic happens in the update colors from notification function. If you recall, we previously created the color updating protocol to provide a common interface for clients to specify themes and update colors. We'll check here to discover whether our color theme observing object also conforms to ColorUpdatable. If it does, we'll instruct the object to reconfigure its appearance to match the new theme. We should now extend conformance to color theme observing to all UI view controllers. From here, we can call our update colors from notification function each time a color theme change notification is received. With this, any view controller, both observing color theme notifications and conforming to ColorUpdatable, will automatically reflect the new theme. Of course, you need to take this one step further when working with table and collection views. Luckily, we can take advantage of extensions here as well. Since both UI table view controller and UI collection view controller inherit from UI view controller, we can override the behavior we defined in that last slide to automatically reload data. But what good is a theme change notification if we haven't specified any colors? If you recall from earlier, we still need to update our custom color roles to accommodate for our new themes. we can define a theme enumeration corresponding to each of our configuration options. Using class functions in our UI color extension, we can specify theme arguments to determine which colors correspond to each style. We can then switch on the theme to return the desired palette colors. To see the theme change in action, have your controller conform to ColorUpdatable. You can see that theme can now be specified as an argument on each color. Register your ColorChangeObserving observer, then post a color theme change notification. Thanks to Swift protocols, that's all you need to do. I've included a link to a sample project I've created demonstrating the color system in practice. Please check it out on GitHub or visit me during my Q&A session if you'd like any additional information. Now, having the ability to customize themes provides a wonderful incentive to begin thinking about your app in new ways. I'd now like to take a moment to speak to you about inclusive design. 1 out of 12 men and 1 out of 200 women are afflicted by some sort of color-limited vision. As you can see from the spectra on the right, the variability in these concerns is staggering. This means about 5% of your users won't ever see your app as your designer intended. Before you begin designing special themes, specifically with color-limited vision in mind, you should know that Apple introduced an incredible color filter accessibility feature in iOS 10. These filters do a remarkable job of increasing the contrast of all colors throughout the entire iOS system. Let's look at an example. On the left, we have an unfiltered image. On the right, we have the same image with a green-red filter applied. If you aren't affected by some form of color blindness, applying these color filters may not be very useful. Of course, if you aren't afflicted with deuteranopia, the adjustments made here aren't relevant to your sightedness needs. In order to get a feel for how to best adapt our color system for sightedness concerns, we need to be able to simulate what an affected person would encounter. Ideally, this solution would address the full spectrum of color-limited considerations. Fortunately, we can adapt our color system to use a library like Inclusive Color to achieve this goal. The leftmost image shows our favorite Tri-Swift mascot as we know and love. The contrast ratio between the color of the bird and the background is a respectable 1.6. In the center image, all colors have been replaced with colors consistent with deuteranopic vision, a form of red-green color blindness. In this case, the contrast ratio between the bird and the background is 1.2, a 25% decrease from the original image. It's still cute, but noticeably more difficult to distinguish. In the rightmost image, the deuteranopic color filter has been applied to the simulated image. This time, the contrast ratio between the bird and the background is 1.3, which is an improvement as compared to the appearance without the filter. With our color system, adding the functionality to generate this simulated appearance is as simple as adding one argument and calling one function in our UI color extension. Although the previous example holds up well when viewed with red-green limitations, I'm certain you can imagine a design that might not. Having the ability to simulate this condition might be useful in unexpected ways throughout the lifetime of your project. With that thought, working with a color system that can adapt in this way may prove valuable. I'll conclude with a few strategies to keep in mind when adding themes to your app. First, note that making use of a monochromatic color scheme should work universally for all users. Rather than relying on specific color hues to determine importance, Using a range of shades will allow users to determine the relative importance of information as compared to that of other elements on the screen. Again, you should make a point to calculate the contrast ratio between foreground text and background elements. Text below 18 points should ideally have a higher contrast ratio than that of larger text to ensure information is legible. You might consider adjusting your font weights in addition to selecting high contrast colors to achieve these target values. And lastly, strive not to rely on color alone to provide feedback for your users. Although the notion of green for good and red for bad is understood in many cultures, those afflicted with red-green limitations might miss the message when other visual cues are lacking. We've covered quite a bit of ground in our discussion today. First, we spoke about the basics of building a robust color system. Next, we were then able to leverage the power of Swift protocols to update our color themes at runtime. Finally, we concluded with some thoughts about considering color blindness when testing your app. I sincerely hope you'll consider integrating these approaches into your own projects. If you'd like to learn more about the concepts we've discussed here today, I strongly encourage you to check out the Inclusive App Design session from last year's WWDC. You'll never look at your app's design in the same way again. It's been an absolute pleasure speaking with you. Thank you so much for your time.
So I'm actually colorblind. I'm that 1 in 10, 1 in 12 males. Does Meetup actually use the colorblind APIs from Apple in their app?
The colorblind APIs?
Yeah.
I'm familiar with the color filter accessibility features, but I'm not quite sure I'm familiar with the colorblind APIs you're referring to.
Those things.
Oh, well, that applies to the system level. So anyone with any form of color blindness can make that change, and it will affect the entire iOS system. So that's your home screen, your lock screen, any app you use. It's a better option than specifying a custom theme in your app because that's so limited to a single, application's experience.
I had no idea.
It's great. It's kind of buried in a menu, but it's really valuable.
Cool. Thank you very much.
You're welcome.
Got more question? Okay. 他にございませんか。では、Thank you, Laura.
Thank you.